So now we're given f of x, the same function as the previous problem, 600x squared times e to the negative 0.012x. And we're to find the average value of f of x, not x obviously, for x from 0 to 1,000. So we're calling the average value from a to b of a continuous valued function f of x is equal to the integral multiplied times 1 over b minus a, or the distance along the x-axis you integrated. So for a quick review, this is f of x. The integral is the area, and we're going to divide by this distance here from a to b. So we get basically the average height of the function, and that'll be our average value. So for this case, since we're going to use a calculator, all we have to do 1 over 1,000 minus 0 times the integral from 0 to 1,000 of that f of x dx. And this could be integrated by hand with x squared and e to the ax. You would have to use integration by parts twice, and each substitution with using u as x squared, it would decrease the power by 1. But we're going to use the calculator, and so the function has already been typed in, so I'm going to pick an appropriate window. We'll say 0 to 1,000 to start. And do a zoom 0. Let it figure out where the function is. And there we see our function. Okay. Average value from 0 to 1,000. So we're going to integrate using second calculate. Integrate is number 7. Lower limit is 0. Upper limit is 1,000. And this will give me the integral part, and we'll simply divide that answer by 1,000. Shades it in, which is handy to visualize what you're finding, and it's telling me the answer for the integral is 694,081,765. A pretty tremendous value, 694 million. Divide that by 1,000, that would move the decimal right here, and we'll have an answer of 694,081.765. Now we're asked to find the area under the curve from 1,500 to infinity. We're going to try and think creatively. Now what we're doing here, integral from 0 to infinity of f of x dx. Now we're not dividing by anything because it's not an average value. This formula up here was, of course, the average value formula. The integral itself gives me the area. But it's kind of hard to type infinity into the calculator. So what I'm going to do is try a successive series, and we're not going from 0, so help if I write the actual correct approach here, 1,500 to infinity. So I'm going to go from 1,500, let's try 10,000, that's a long ways from 1,500, and then we'll try 1,500 to 100,000. And here's what we're thinking when we integrate f of x with these kind of limits. First off, the integral to infinity. That means we're going to go out along the x to infinity. And for that to work, the function has to be heading down towards 0. If the function was not heading down towards 0, this area would obviously be infinite. If we keep adding, for example, even if it was heading down to the line y equals 1, if you keep adding 1, which each of these rectangles would be forever, your answer is infinity. So the only way to get a not infinite answer is the function has to be approaching an asymptote here at 0, y equals 0. Which this is, as we can see from the graph, it's heading down towards 0. But what we're going to try and do is integrate it to some large numbers and then larger numbers and see if that answer seems to be approaching some kind of limiting behavior. So let's change the window. Obviously, I don't need to start at 0 anymore. I'm going to start at, say, 1,500 and 10,000. Do a zoom 0 so it gets a quick fit for me. And we see that it is going down to 0 very quickly. So it's doing what we need it to do. And we'll second calculate. Oops, second calculate. Number 7 is integrate. Lower limit 1,500. Upper limit, we could even do 1 to 5,000, I suppose, and start our process off a little smaller. Keep writing 0, 1,500 to 5,000. And if I integrate that, I got 1914.3238. Second calculate, we'll integrate it again. 1,500 to 10,000. Doesn't look that much different than it did at 5,000, and I get 1914.3238. So I'm already fairly convinced. My answer must be fairly near 1914.3238 because it isn't changing. So what this is telling me is if I look at what happened to 5,000, I'll go 5,000 here, 1,500 to 5,000, that area, and I add it into 10,000, it's so small that the calculator is not able to even detect that. So we're going to see the same thing at 100,000, and I'm convinced my answer is around 1914.3238. It's an approximate answer. To do this out formally, what one is actually calculating is the integral from 0 to a of f of x dx, and we're taking the limit as a goes to infinity. So unfortunately, in this case, it would require integration by parts twice to get a formula, and then we could finally substitute in a and try and take that limit. And it can be done, but I definitely want to point out the technology way to get a numerical answer to this problem.